Let f of x be defined as the piecewise defined function 4x plus 7 if x is less than 4, and 35 minus 3x if x is greater than 4. Determine whether f of x is continuous at x equals 4. If f of x is not continuous, identify why. To answer this question, what we need to do is identify a few different pieces. So first off, continuity. What does that mean? So continuity exists if the limit as x approaches some point of a function is defined, and f evaluated at that point is defined, and those two pieces are equal. So we really need to check these three things. So first off, what is the limit as the x approaches a of f of x? So the limit. To do that, we would do the limit from the left, so the limit as x approaches 4 from the left of my function, and the limit as x approaches 4 from the right. So as I approach 4 from the left, I would be looking at values that are smaller than 4. So all of those values would go into this particular function. So I would observe what's happening with that function and try to get a limit. Now, I can use the properties of analytic limits to do this, so this would really just be 4 times 4 plus 7, so 16 plus 7 is 23. Then the limit as x approaches 4 from the right. Those would all be values that are bigger than 4, so I would be looking at observing this function, which would be 35 minus 3x. Testing analytic limits first, that would mean I would be doing 35 minus 3 times 4. So 35 minus 12 looks like that's also 23. So what that means is comparing these two, because they agree and they are equal, that the limit itself is 23. So now we need to check out f of a. So that's just evaluating f at 4. Well, if I try to evaluate f at 4, the thing is, neither of these intervals here involve the value 4. So f is not defined at 4. So f does not exist at 4. So that does not exist. So it's not continuous because the function does not exist there. So the reason we choose the second one is because that function not being defined at that particular point.